Okay, good afternoon, everyone. It's really great to be here. Last talk of the day, you are probably all very tired. I am too, but it's NASSP, so we don't have time to be tired. Whoa, okay, so I think we started from the back. Okay, so we are really tired then. I'm tired then, I think. Is this a pillow? Okay. Anyway, so I'd like to start by thanking the organizers for inviting me, Patricia, Ross, and then the support staff, Nikki, who were very instrumental in organizing, so many things for us, our plane tickets, accommodation, all of that. Thank you, all of you. Also, it's really great to see, all our lecturers in one venue from, back then. I'm from the 2010 cohort. Maybe let me advance my slides. The stories since we started the day are really wonderful. This is really more reason to have NASSP continue doing this wonderful work that it has done over the past 20 years. I mean, the testimonials, people were first scientists and then they left, and some are now working in government and they did quite a lot of work, like or people like Benny Fanarov were not in the NASSP, but it's a Benny Fanarov, for example, story, who now works for the government, I think. Is similar to the stories of some NASSPs that have been shared. So NASSP impact in that sense has really been very monumental in both, training people for academia, for research, astronomical research on the African continent. So that's really something that is very commendable, and I think we should probably give ourselves a round of applause for having done a good job. Especially to the people that started this work and the management and so forth. Anyway, I thought I could take also, a minute or two to just, maybe 5, to just share about, my journey also in NASSP. So this is what I'll be talking about, Astronomy in Namibia, the team that's in Namibia, after I've shared a few words about my NASSP journey as well. And then Astronomy in Namibia with SALT. I'm in Namibia, but I'm still actively linked to SALT. And then Astronomy in Namibia with HES, AMT, and then some outreach activities, and hopefully I can still be within the 15 minutes to share some future plans. I've already spoken about the first bullet. So I'm from the 2010 cohort, as I mentioned earlier. I did the master's in 2013. I graduated mid-June. No, not 2013. 2011 to 2013. 2013 is when I graduated from master's. So this is us. I am the top right. And then, so as you've heard earlier on, a lot of us, that have undergone the NASSP training are not astronomers today. A lot have gone into different fields. Same thing here. In this picture, I think it's about 30% of us that are still practicing astronomy. The rest are really in different fields. Some are data scientists, others are, working in consultancy services, some in business and finance and so forth. How did it start for me to join NASSP? For me, my story is slightly different because actually having gotten reasonably good grades in physics and maths, I think that's how we all ended up in NASSP. We must have had good grades in those, in those subjects in high school. So I came to university and everybody couldn't understand why I was not doing pre-med or pre-engineering. At the time, at the University of Namibia, which was the only university we had at the time that was offering those kinds of programs, it didn't have, the medical programs or the engineering programs. So those were only in South Africa. So you first go through a pre-training before you take on before you can get accepted into an engineering program or a pre-med program. So we would share like physics classes and first year physics classes and maths classes with the people that were doing pre-med programs. And they wondered why I was not in the engineering programs because I was reasonably performing very well in the physics and the math. And I told them, I actually want to be an astronomer in the future. That's why I'm doing this. And they say, but where are you going to work, you know? And, you know, I didn't know where I was going to work. I mean, it was not easy to actually find information at that time. You know, in the early 2000s, we would queue up, you know, to just use a computer, to really just use one computer to access web pages or what have you. And either our teachers didn't also have information. You know, if you say you wanted to do this and this, they were also just limited in what they knew. But I'm just like, no, leave it alone. I'm not going to do pre-med. I'm not going to do pre-engineering. I'm just going to do this. You know, I don't know what's going to happen after that. And they would say, oh, you're just a book smart. You're book smart. You don't know the ways of the streets, and you're not realistic. But anyway, you know, long story short, I ended up actually working for NamPower because then, really, they were right. Because then they said, yeah, we told you so. I ended up working for, you know, an electricity supply company, the equivalent of ESCOM for Namibia. Sorry. So then finally I had a computer and I had an internet that was just, you know, an internet connection that was just dedicated to me alone. So now I could go on the NASSP website because one of our physics lecturers told us that there is a program called NASSP in South Africa, you know, at UCT. You could maybe get in there. But then I was locked into this electricity company because they gave me the scholarship. And I was obliged to work for them for the same amount of time that they sponsored me for, which was 4 years. So I finished in 2004, my undergrad, and I had to work for them for all those years until I could come to NASSP eventually. But what was happening was that because I was not interested in what I was doing, because I was doing finance work, right? And I wasn't really interested in that. I was modeling, you know, the cost-benefit analysis of adding new power stations to the grid. And it was quite exciting when it started, but then later on it got like routine work for me, and then I had to prepare board reports and that sort of thing. So I would download the NASSP curriculum, and when I had a gap in my schedule, I really just locked my door, and I was happy. It's like I was in class. I went on the gallery, I could see Melanie Spark, I could see Paul Kotze, I would see all these guys. I was envious, right? Like I really just wanted to join them. But then, you know, after the 4 years was done, you know, I applied and I got in. And I never knew the meaning of tears of joy, but like, I thought that was just a made up thing. It was a marketing thing to sell stuff. But I stood there looking at this power station that I was ordering coal for from South Africa through a tender process, a process that I really hated. And I saw, you know, the chimneys, smoke was going up those chimneys. And I was looking at that, I'm like, yeah, I'm not doing this again, yeah. And then from within, I just started feeling some kind of weird feeling, and tears were running down my cheeks. I'm just like, wow. Okay, so these are the tears of joy then, because by then Peter Dansby had sent me an email saying that, oh, you've been accepted for, you know, for the honors program, and you'll get this and that. So that's how I ended up in NASSP, actually. Anyway, so what do I do now? And just to add that my supervisors were Steve and Bruce. A lot of you would know those, because those are where, you know, they were some of the people that we really have to work with. They were quite strict in what they were doing, which I only got to appreciate later on, you know, because I thought, I don't know, I think if you have an experience and you say later on that, actually, that was worth it. Because at the time, I felt like Steve and Bruce were very hard on me and they were inconsiderate and everything, but after I graduated, they were also my PhD supervisors. After I graduated, I always look back and I'm just so thankful to Steve and Bruce for their unwavering, you know, way of doing things. They were very pedantic about what they wanted you to finish by this date and that date. And now I hear those stories in the corridors at my university. Like, oh, no, don't go to Dr. Kasai because, you know, he's mean. He's this, you know. But then they forget I was once a student as well, and you know, so I just I always say to myself, they will appreciate it someday. Hopefully they will, you know. Anyway, post NASSP, I am now a senior lecturer at the University of Namibia. I joined the university in 2016. I actually didn't finish the PhD. I had to go back because I had gotten the position. So I was finished writing up there. Then I came back for graduation in 2017. But by then I was already a lecturer there. Then I got promoted to senior lecturer in 2019, up until position that I have up until now. So is that 5 minutes later now? 4 minutes. Oh, very good. Okay. So then I've served as an HOD for a new department, Physics, Chemistry, Material Science, since 2021. I really had to step down from that towards the end of last year. And then I am the principal investigator of the SALT program now for measuring redshifts, which I'll talk more about later on. And then DARA that you had from Wendy, Wendy spoke about DARA in more detail, so I don't have to expand any more on that. So I'm the coordinator of that for Namibia. And just yesterday we received an email from Melvin, who's the project lead from the University of Leeds, that we've gotten phase 3 funding as well. So we'll do more DARA training. I think the scope has been widened now. The university is now able to employ like a DARA postdoc as well, and we can have master students and so forth. Then I've been an IAU, National Outreach Coordinator for Namibia as well since 2017. So that's kind of been the journey from when I finished up to where we are now. So Astronomy in Namibia. So this is the team. Just drink some water quickly. So I put UNAM in brackets because all of us are really based at the University of Namibia, and there are no, other universities don't have any astronomy activities going on there. So this is our team. We are a combination of, gamma ray astronomers and millimeter wave astronomers and optical astronomers. Since 2019, I've been moonlighting a bit in gamma ray astronomy. This is where I do now. The work I do with SALT is based on that. So it's like a combination of optical and gamma ray, which I'll demonstrate further. So this is the rest of the team. And then there's this PhD student on the first PhD student on the African Millimeter Telescope. I'll touch briefly on that as well. And then we have a vacancy, speaking about advertising. I'm advertising as well. We need a professor, if you know anybody, to be appointed by the university. We've been, how's it?
2 minutes.
Oh, okay. Yes, anyway, so it's measuring redshifts that I'm involved in. So it's really to support the work that's done by the Cherenkov Telescope Array, which is the next generation of ground-based imaging atmospheric Cherenkov telescopes. So all of these main areas that the CTA, main science cases that the CTA is being built for, there's a host of others, but these ones specifically need redshifts. This diagram here in red demonstrates the importance of redshifts. So if your object is located at 2 million light years, this is what the spectrum would look like. Your spectral energy, a portion of the spectral energy distribution in the gamma ray range, this is what it will look like. If it's at 2 billion light years, this is what it will look like. So all that happens is the extragalactic background light photons that actually interact with the gamma ray photons, resulting in an absorption that interaction results in pair production, where you have positrons and electrons. So from there you can have all kinds of physics, like the Lorentz invariance, the Lorentz invariance violation constraints, or theoretical predictions. And then there's this concept of axion light particle, where you have the gamma ray sort of putting on a cloak as it travels from the source to your detector on the ground. It keeps on putting on this cloak, and then it cloak oscillations could all be tested with the Cherenkov telescope array because it has the energy range and the sensitivity to be able to detect this. Even a negative result will be appreciated, as they say, these guys in these spaces. That's not the work I do. That is just to say the redshift measurements is key to all these investigations, because if you don't know that, then the shape of your spectrum is not known for sure. So that's the contribution that we have to that. So we've been doing this project since 2019. So we've published 3 papers. I led the second one. The third one has just been accepted. So far we've measured up to 37 redshifts of blazars, BLX to be specific. And then just to highlight here that, when you have a high signal to noise spectrum, it's not a guarantee that you'll measure the redshifts. For example, here in the first paper we had very high signal to noise spectrum. We were 9 out of the total sample, we had 9, but we could only measure a fraction of those. So high signal to noise spectrum is not a guarantee. It actually depends on how quiet the source is in terms of its black hole radiation, the relativistic jets, how bright those are. That's what determines whether you can measure the redshift or not. It's a very difficult process. The techniques of doing that are very, you can be cunning, you can be clever in how you can achieve that. It boils down to you really being clever on how you can, model your conditions and, place your slits and so forth to try and get the redshift out, but it's a very difficult exercise. So astronomy with HESS, this is the HESS energy range. These are the largest, ground-based imaging atmospheric Cherenkov telescopes. The bigger one is 28 meters across. The smaller ones are 12 meters each. I guess the first generation of NASSPs would know, from Prof. Orkideyage's lectures, you would know how this works, where you have a gamma ray comes in and it creates a particle shower. Then it creates this blue light that then the telescopes on the ground pick up. So it's basically an optical telescope, but it's an indirect detection of gamma rays. So you need at least 2 of those to reconstruct the path from where the gamma ray came from by measuring these particle showers. It's a collaboration of 250 institutions. So it's quite a huge collaboration. So a lot of the papers that come out of this telescope is actually collaboration papers, but members of our team have actually gone on to, to write non-collaboration papers using data from HESS, which I thought was quite, an achievement by these guys that work in this gamma ray regime. So then we were fortunate enough to actually secure funding in 2018 from the GCRF. So we got about 6 million, over 6 million in 2018. So the European partners were pulling out funding slowly in the telescope, but we secured, over 6 billion rand, as I said, to continue running the observatory for between 2019 and 2021. COVID challenges, came along, and then we were allowed an extension. So this was between Prof. Garrett Cotter at Oxford University, my colleague Michael, and myself. And so I'm happy to say that 30 publications actually came out of that, collaboration publications. Some are non-collaboration publications, a few authors. Then I think because of time, Roger already touched on this, astronomy in Namibia with the AMT. So it's just to say that, same thing that Roger said, basically, with the addition of another telescope in Namibia would introduce this, these additional baselines with all the telescopes currently in the EHT network. So this simulation here shows, with no AMT in the system, If you integrate for those amount of hours, this is what you would get. Roger, correct me if I'm wrong, this is not my area. But if you add the AMT for the same conditions that you're running the simulation for, this is what the image looks like. And as Roger said, you can actually make movies of Sagittarius A*. So this is where the telescope is supposed to be built, almost finishing up. The funding for doing science has been secured. I think, close to over 90% of it has been secured. The issue we sit with now is really getting this road constructed, because that's a challenge, as you can see. I've heard, people apparently praying quite a lot when they go up that mountain. I don't know if you were praying, Roger, when you some praying for the first time, apparently, also. So that's really just the challenge. Though this is the telescope that is supposed to be used for the AMT. It is to be refurbished still. There are other considerations that we've been hearing about, but simulations are being run. I think it might be that it might not be built there. It might be built maybe near the head site or something, because of all these challenges of getting that road right. But we wait to see. But nonetheless, we still want to really develop this site, because it has a lot of astronomical potential for multi-wavelength observatory. Single mode dish, the single dish mode science, I should probably skip that because I'm not an expert, but you can do star formation studies with that. I think James from Northwest University proposed this, like doing water maze observations, H2 regions. You can do star formation studies with that. And then AGN monitoring, Michael wrote a paper on that. And then this professor that we've been really hunting, it's very difficult to find a millimeter wave astronomer, it seems, is supposed to come and sort of help with identifying more single dish science mode. But the whole idea is that when the AMT works in a network with the rest of the EHT telescope, that is going to only be for less than 50% of the time in a year. So the rest of the time, it's available for single mode dish science. Single dish mode science. I wanted to say something about the outreach project that we have with the mobile planetarium. It's really taken off in the last few months. A lot of sponsors have come on board. We have Nedbank Namibia that has come on board, who donated to us 450 rand for the next 3 years. 450,000 rand. Oh. Yeah. 150 rand a year. Okay, 450,000 rand a year. You must forgive me. I was watching. I needed to know if we're going to make it to the next stage in the AFCON Cup. Sorry. Last night. So we have Fly Namibia, who has donated also they've come on board. They've made available 2 flights, not per year, but per month, to the mobile planetarium operating team, so they can fly them, to like the remotest places that are very difficult to get. Namibia is quite a huge country, so we're very appreciative of that. But then there's also Gondwana lodges, who have promised, or they've made to us, free accommodation to our mobile planetarium operators, free meals. So that's really, if they find themselves in a space or operating a planetarium show at a school, and there's a Gondwana lodge nearby, they can overnight there for free and so forth. So these are like the really main sponsorships that we've had. Then we have all those other sponsors also on board. So far we've reached more than 10,000 visitors in the planetarium, and we hope to do more. So these are just some pictures. And just to highlight that this is a student-operated project. So it's actually our MSc students that have been trained to operate the mobile planetarium software. They're the ones that go around conducting these shows, and then we just give them the support. And then we got, as a result, because we did quite a lot of shows last year, we were awarded this Annie Monda Medal for outreach just a few weeks ago, about two or 3 weeks ago, for the outreach work with the mobile planetarium that we did during last year. So I think that's that, and then these are just some future plans. It's basically just, to try and push the government to build that road up the Gamsberg Mountain so that we can try and turn this place into sort of a multi-wavelength observatory. And we've written a strategy on that, which we got recently published as a book chapter in a book called Southern Space Studies. Thank you very much for allowing me more time. Thank you.